Attention class, welcome. This is the last day of the semester. I cannot believe it. I really can't believe it. But we're there, the last day of the class. I'll just say it's been a ride. I'll tell you, it definitely has been a ride. But before I get into any of those kind of like, sad, soapy moments of crying, being like, you're at the end, congratulations. Let's get into chapter 12. We did not have class on Wednesday. I think I saw some of you at the event yesterday for the extra credit. I'll go through and make sure I put that in there and give you guys the promised extra credit. Like I mentioned, for attending that event. It was a good turnout. Those who did show up, I appreciate it. The other thing we'll do is just really get into this. Now, this lecture is going to be a little different from what I've done before. The reason why, because I think the basic understanding of it is very similar to what we've already done for 12.1. So I'm just going to go through this in a different way. And honestly, I'm probably unprepared. I'm trying to hide that I'm unprepared by doing this lecture. And I say that because what I did last year was an assignment. It's an assignment that pissed people off. And I just thought it was a great way. And again, if you guys remember, we didn't do the labs this semester, like the lab that I was trying to do for everyone. But this right here is what kind of made me want to do that this semester of the course that we're going to go into. I'm going to talk about how it's kind of a bit relevant and maybe help you guys get with this context, just to really grasp what we're trying to talk about when it comes to chapter 12, analysis of variance. We know that, ANOVA, but then now specifically the two-way ANOVA, right? So let's go down to this little story that I had done before. Okay, now this is an assignment that I did last week. It was like kind of after COVID. Y'all realize it's been about a year since COVID, like a year and a month now, probably, because year and a month since COVID hit us, right? A year, a month and a half. So at that time, we got to a point where everybody was just trying to pivot. We're trying to figure out what's going on. I created this assignment. And this assignment, actually, I think some of y'all might have been participants in this assignment when y'all was trying to be socially distant in what you were doing, right? This is what I did for the students. And let me tell you, some of these kids were angry, right? So instead of having class for a week, right, we did an alternative assignment that provided them last week. Now, again, please follow me. This is hypothetical. This is not what you guys have to do. I'm just trying to give you a context of what we did last year, tell you their experience, and then talk about the data that we got from them last year. Take down your notes, relax a little bit. This is not what I'm asking any of you to do now. I'm just reminding them. Now, this is the kind of things that you needed, right? A refrigerator, 2 slices of bread, right? And that's per participant, depending on how much credit you're going to do. Ketchup and peanut butter, right? Now, what you're going to do is you're going to collect data from up to 3 other people on the following task, right? For each participant, get 2 slices of bread, right? So if say it's yourself, right? You get 2 slices of bread. You're supposed to cut these 2 slices of bread into 3 pieces like this. So it's like right down the middle. And then on one side, you cut it in a quarter, but not the whole thing, right? Now you put peanut butter on one of the quarters, which is right here, ketchup on another quarter right here. And then on the one that's kind of a half, you put ketchup and peanut butter together, right? And what you do is, as you can imagine, you sit back and you fold the peanut butter and ketchup thing by itself, and you eat a peanut butter and ketchup sandwich. I have to feel bad because not only did I make these students do this last year, I didn't even try it. I was just like, it'd be funny to mess with them. And that's exactly what I did, right? Now, here's the issue. People had no problem eating the peanut butter together. Peanut butter by itself. People had no problem eating the ketchup by itself, even though it's kind of weird, but we know and we like ketchup, right? But ketchup and peanut butter together, biting into it like it was a sandwich, whew, that was a lot. That was a lot, right? Now, what they did is, in addition to that, there was another issue. I mentioned that you needed a refrigerator right here. So you would make 2 pieces of bread for each person. So it's not just getting this piece of bread right here and cutting it up like this. You would do the same exact thing for another piece of bread. But that other piece of bread that you would cut up, you would put that in the refrigerator for 4 hours, right? So you get your, I'm gonna say your mother, right? Your mother is the individual who's doing this. Your mother must eat the piece of ketchup that's room temperature, the piece of peanut butter that's room temperature, the peanut butter and ketchup sandwich that's room temperature. Then they go to the refrigerator, pull out the ones that's cold, been in there for about 4 hours, right? And then you got to eat the version that's cold, right? Now, of course, there's a little survey I created, right? The survey was in D2L, right? And what you would have them do is they would go right through and they would rate how they like these things, right? Now, I'll tell y'all can sit back and think, some of this stuff sound nasty, right? It's so funny because everybody knew the peanut butter would be fine, right? Now, when I'm telling you that the ketchup by itself was fine, that's only from what we learned, right? People thought like, ew, why would you just eat ketchup by its? They thought they would hate it, but it was like, okay. Like, I don't think anybody made a ketchup sandwich, but it wasn't bad and it was rated pretty highly. Now, the peanut butter and ketchup together, that actually was unique because some people didn't hate that as much as they thought they would either, right? So it really was like research, right? Because when I told them this assignment, they thought they were going to hate it. Let me tell you, I had people coming out the woodworks with all types of lies. I don't got no bread, right? And I'm sitting over here thinking like, you don't got bread? I'm like, that's fine. Even if you don't have bread, I'm sure you got a family member that has bread. You can do this virtually. Then I don't have ketchup. I'm like, then you know what? If you don't have ketchup or you don't have peanut butter, then call the next person in your family and do it. You need 4 people total. So if you don't have it on campus or you don't have bread, that was the other thing. I'm like, damn, y'all don't have bread. But again, everybody ended up getting it. They were trying desperately to try to find a way to make them not be able to, but they all did it, right? And it wasn't as bad as they thought, right? It's intuitively, it kind of sounds nasty, but it's not bad, right? Now I mentioned they had to rate each of these 6 things, right? So each participant had these 6 pieces of bread with these different combinations and different temperatures, and they had to rate them. This on this next slide, my goodness, how come it's not moving? This next slide right here shows what happened. What was the data? Now, for everybody in the class, this was what I also did. And it's real funny how people went from, I don't want to do it, ill, to, right, to everybody did what they were supposed to do, right? The assignment also said this: if you get one person to do this assignment, which could be you, right? If you got one person that would do this assignment, you would get a 95% on this assignment. All you got to do is take a picture of yourself. I did want to see some pictures, right? Some pictures, one person do it, you got a 95% on this assignment. If you get, I think 3 people to do it, right? You would get 115% on this assignment. And if you got up to maybe 5 people, I forget how many the numbers were, but the more people you did, the greater your grade was, right? And so people go from trying to throw all these things out to getting a good number. We actually had 48 people from the, I think maybe 10 or 12 people that were registered into the class. We had 48 people complete all these ratings and had photos. I'm telling you, you had one person had their, I think it was their sister was giving me the middle finger in the camera. Like they took a picture about to eat the sandwich, but they wanted to sit back and be slick and give me the middle finger, right? I just laughed because I was like, you know what? You the one that still ate peanut butter and ketchup. But this is the data. This is the data that came from it, right? Now I mentioned the ratings were on a scale of 0 to 5, I believe. just like I said before, peanut butter sandwich, we know that's good, right? Peanut butter, a ketchup sandwich by itself, room temperature, it wasn't that bad. And people were putting comments in there too, just being like, all right, you know what? It's just weird. It's weird to think about it, right? Now, think about this. Let's make a cold peanut butter sandwich. A warm one's probably preferred. That's what we see right here. On average, across 48 participants, the warm one is, overall, the cold sandwich probably just wasn't as good as the warm sandwich. Same thing with ketchup. Not only is it weird, but you just made it more weird by having it cold, right? And look at this. Again, just like we thought, peanut butter and ketchup, it was the most preferred item. Although if you really attend to this, look at this standard deviation or the variance. Think about this. If the scale is 1.8, that's what this pretty much is for a warm peanut butter and jelly sandwich, right? That means on average, people were rating this as high as, what's 1.7 plus 1.4? That is a 3.1. We had ratings on 5 as high as 3, but then we also had some ratings that were as low as 0. People just saying that they hated it. I think that's one of the ones that got the middle finger in, right? But again, we're just looking at this data. So have them doing this assignment when we're in here talking about the analysis of variance, the two-way factor analysis, they really understood it. They really got it. And I want to make sure that you really get it and you really got it by asking you guys, right? There's 2 factors. There's 2 factors here. What are the 2 factors that is appropriate for this study? Just give me one at a time. I want to have a little bit of multiple contributions. So just give me one. 2 factors in this study. What are they?
Is it peanut butter and ketchup?
Now you know what? I need to be nice to you because you tried. Everybody else is scared, right? It's not peanut butter and ketchup, right? But I'm glad that you wrote that out. And you know what? I could maybe get away with half of that. I'm gonna add to that. I'm gonna make you right. PB and ketchup, right? Now, one of the factors, right? I'm gonna tell you this. Doesn't have to be wisdom, but she gave us the levels of one of the factors, right? The levels of one of the factors is peanut butter, ketchup, and then another level was peanut butter and ketchup, right? But factor is something complete and global that includes all of those 3 things. Now, it hasn't really been shared here, but somebody has to sit back there and think, what would be a global name or category for the factor that would include peanut butter, the ketchup, and the peanut butter and ketchup? Somebody other than wisdom. Wisdom already taught. Don't be scared, people. Wisdom attempted, she wasn't right, but she got us to where we need to be. So what's the worst can happen if you try? All right, I think what's happening is y'all on the other side of y'all mics forgetting that you're muted and I can't hear your contribution.
Would it be N in the average?
All right, N and the average, no. And again, the question I asked was this, right? Peanut butter, ketchup, and PB and ketchup are 3 levels, right? Now, That's it. I'm asking for the name of the factor, right? That would include all of these. What would be the factor that would include peanut butter, the ketchup, and the peanut butter and ketchup that we use? And you have to have listened to what we were talking about before on the previous slide. What did we use peanut butter, ketchup, or peanut butter and ketchup for? Oh, got something in chat, I think. All right, this is what I'm going to put. It's, I'll call it bread topping. Right, so when you do the bread topping, that's one of the factors. Now there's 3 levels of bread topping. Depending on which piece of bread you pick up and eat, you either got the bread topping with peanut butter, you either got the bread topping with, what's another topping can be on it?
Ketchup.
Or you got the bread topping that's somebody else.
Is it warm or cold? From the freezer or something?
No, not on the bread topping.
Oh,
First is peanut butter, then is ketchup. The last one is peanut butter and ketchup. Both, exactly, right? So one factor is bread topping. Now, this is a 2-factor analysis of variance, right? What is the other factor that we manipulated in this little research project?
Warm and cold.
Warm and cold, all right? So again, she's giving me the levels of it, warm and cold. But now I want to ask for, okay, what's the name of a factor or a category that would be inclusive of warm and cold? A little bit of critical thinking here. And you know what? I'm looking for some people that have not contributed yet, and at least ideally. I mean, I ain't gonna wait the entire class, but don't be scared. What's the name of the other factor that would include warm and cold? And there's no real right answer. You got to understand and follow what we're doing. You got to be willing to take a risk.
Would it just be like temperature?
You know what? The only thing is wrong with what Siani just did is that she gave it in the form of a question, right? Would it be temperature? The answer is yes. And you know what? I was ready to sit back there and type in bread temperature, right? But again, just because I didn't say exactly temperature, right? Temperature, and the 2 levels are warm, cold. That's right. She took a little stab at it, warm and cold. So this study right here, right? I want to sit back and let y'all know about what's going on. We talk about designs like this. We describe them from using a form of notation, right? Now, this right here, the notation, what we do is we'll call it like a 2x2 design, or a 1x4 design, or a 3x4 design, right? And that design is always relevant to the number of levels in each of the factors, right? So if we were to have 3 factors, right here, we only have 2. We have temperature and we have bread, right? So that means our study is going to be let's say a 2x2, right? If we were to have 3 factors, I don't even know what we could do right here. Say we did, I know what we could do. What if we looked at whether or not people drank it with milk? Right? So we have a factor of temperature, bread topping, or with milk or without milk, right? Then that would be a 3-way design. So it would be like a 2x2x2 possibly, right? But not forgetting our context here. Since we have 2 factors, first one is temperature. The second one is our bread topping, right? We have 2 factors. So our design is going to be probably like a number by number design. Right? Now, this number that we put on here is going to be consistent with the number of levels we have. In temperature, how many levels do we have in temperature?
2.
2 by, how many levels do we have in bread topping?
3.
So we have a 2 by 3 two-way analysis of variance. And that's only from, you can only get that from looking here. It could be any combination. Like in another class, my research methods class, they go into detail. My dissertation was a 3 by 4 by 2 design. That is extremely complicated to be able to follow, but an analysis of variance can allow you to do that, all by controlling it, right? So, okay. I think that's all we want to talk about on this slide right now. Again, with the context of what we're doing on this right here. Now, we had some people mentioning what N is. N, capital N at least, that's always your population, how many people are in your population, and or your sample size. N is always that. That's kind of a basic thing that I want to make sure we can always get to make sure we understand that. N is always the sample size or how many events. Capital N means that we had everybody in the population, which is rare, but sometimes Excel's not professional SPSS software. So I think they put N in there, even though it really should have been a lowercase n in my mind. All right, any other questions or things that people want to make sure they understand from looking at this summary table? Because this summary table is showing us some of the descriptive statistics. Descriptive stats. I think I heard somebody take their mic off. All right, it's a lot of time. Nobody has expressed that they want to know more about what's on the screen. So I'm going to move on. Okay. Now, this right here is actually showing the mean data. And this is what the textbook even talks about. Now, they talk about when you plot graphs for two-way analysis of variance, there's something that's called an interaction graph, which is exactly what we have right here that we must look at. The reason why using a two-way analysis of variance is superior to just doing a one-way analysis of variance on temperature and then doing a completely separate one-way analysis of variance on the bread topping, we can look at an interaction graph to see if in our study, bread temperature and the type of topping, right, had some type of interaction with one another. Now, what the chapter goes into detail and says is that if the lines are parallel, and these lines are parallel, they don't have to be straight and parallel, but if the lines are parallel, then that's nothing there. It's nothing that's interesting. Parallel lines mean that there's no interaction, right? That just means that the type of topping, peanut butter, ketchup, peanut butter and ketchup, it impacted the taste of a warm sandwich the same way that it impacted the taste of a cold sandwich. In the same exact way. There's nothing special about that. Now, it would be special in the event that our graph looks something like this. I'm going to, okay. I'm going to erase this. And we're going to play a little game of what if, right? What if the scores for the warm sandwich, right, were the way it's depicted? However, for the cold sandwich, something funny happened, right? When it was ketchup, wrong line. For ketchup, the values were right here. For, no, this is peanut butter, my bad. For peanut butter, the values are right here. For ketchup alone, people was just like, yo, I ain't gonna hold you, Dr. Barnes. That peanut butter sandwich was on fire. I don't know who the hell would say that, right? But the peanut butter sandwich is on fire. And you know what actually made it even better when it was cold? Because it tastes like, somebody said they left it in the refrigerator, but they didn't cover it. So the bread got hard, right? So it tasted almost like a granola bar, right? What if everybody did that, put it in the refrigerator for 4 hours, it got too hard, and it tastes like a granola bar. So she was having what she liked. And everybody was like, yo, that ketchup and peanut butter was also on fire. So the ratings look like that. So when we sit back and look at what it looks like for eating a warm peanut butter, ketchup, and then peanut butter and ketchup sandwich, it's kind of what we kind of thought, like yuck, no, all right, yuck, and yuck. But when we made it on cold bread, it was, peanut butter was good because we like that, right? But the ketchup I can't even say this without getting a bad taste in my mouth. The ketchup was actually better. And then the ketchup and peanut butter for some reason was even better than that, right? This is an interaction. As you can see, these scores, because I'm plotting the means of these conditions, they are not impacted by the type of bread topping, not type of sandwich, but like the topping, they're not impacted in the same way. So there actually is an interaction. And that's the value of doing a two-way analysis of a variance as opposed to doing two separate one-way ANOVAs, one on temperature and one on the bread topping by itself. If you don't do a two-way analysis, you'll never be able to see this. And the interaction graph allows you to be like, yo, something really went down with this experiment. Let me talk about it. All right, did that help anybody or confuse anybody in terms of the interaction? I think it worked for me, but like I said, I think I'm becoming a bona fide stats nerd. Y'all are too, but yeah, I might be the leader of the pack. Anybody lost, confused, want me to go back over this?
Becoming a nerd, you've always been one.
You can't call me that, Narish. You've been in the nerd club with me. I keep saying this to all y'all. Most
I
of
am
y'all are smarter than I am. The only thing that separates me from y'all is that I read the textbook yesterday, this morning, because I was nervous about looking like an imbecile. Most of you are smarter than me. That's it. I just read. I read beforehand and I plan. Don't put me on a pedestal. I mean, I'm not saying I'm the dumbest person, and I'm not saying I'm not smart, but I'll tell you, many of you guys, and honestly, when we were doing it, we stopped because it didn't seem like people wanted to improve their grade in this class. But when y'all were doing the, on Mondays, when you guys were going over the homework and assisting, I mean, I know some of y'all probably felt a little uncomfortable, a little unnerving. I mean, not this year because I'm becoming like a bona fide stats nerd, but yeah, when I first started teaching in the second year, I've been teaching this for 4 years. I think I probably felt like many of you felt. Like, thank God that PowerPoint is there to make sure I don't mess up. And I can kind of sort of do it. Don't put me on a pedestal. I don't need to be. But y'all forgetting the whole point. I'm asking if y'all need points. We get into this conversation about Narice trying to call me a nerd. Unreal, hurting my feelings. It's Friday, the last day of class. She gonna call me a nerd.
It's my last class with you. I had to.
All right. So that's what an interaction graph looks like. This is what really happened. But again, the reason why you can visually look at them and kind of see like, oh yeah, something funny going on right here. All right, let's move on to the next. Now this is like the real data, right? And I wanted to sit back there and show y'all as a little reminder. Actually, this year, again, the stats class in my mind gets better and better each year. As long as we get people that participate and do what we're supposed to do, right? But I think I kind of relayed to you guys about how to understand and interpret this. Let me highlight it, the color I want. This right here. I don't want anyone to look at this and be like, oh, the value is 1.3. Oh, no, 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 no. That e to the negative 29 is actually this, which is actually interpreted as this, what they're saying is they're writing a 1.3 e to the negative 9. So what they have done, watch my math be off, right? The decimal started off here, and they moved this backwards 29 spots. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So that's where the 0 really is. Now, if y'all pay attention, when we look at some stats, we usually only have to what, like 3 decimal points, 3 or 4 decimal points max, right? But what they did in order to save space, because they don't want to tell you that the value is 0, because it's not 0. It's actually 0.00000, all that down to the 1.3. They'll give you the information in what's called the scientific notation, right? But for you and me, this value is 0, right? That's the p-value. And the p-value, we always check the p-value to make sure that the p-value is less than what? P should be less than what?
0.05.
0.05. That first 0 always messes me up. P less than 0.05. Yeah, when I was in grad school, let me tell you, it's so hard to get out of it. But I would always say P less than 0.05 from like my doctrine and my group and cohort. So when y'all say the 0.05, it hurts me. I'm just like, what the hell? But yeah, you're right. You're right. P less than 0.05, right? Is what the value is. So we'll come back to that number a lot. Now, when we ran the analysis of variance on this, right? This is the power of what we get, right? Remember I told you how the two-way analysis of variance is so much more powerful than if you were to just do a one-way analysis of variance. If you did a one-way analysis of variance, right? On this right here, the first sample, this would be temperature, right? I'm going to actually write this right here. This right here is temperature, right? And then this one right here is, I'm going to say topping. I think I said toppings on the previous slide. But if we were to do a one-way ANOVA, right, we would only, this table would look just like it is, right? But the information right here, wait, hold on. This information right here would not exist. So the table would look like this. It would tell us about temperature, right? We had warm and cold, 2 groups. Degrees of freedom is always the number of groups minus 1. So that's why we got the 1 right here. These values are all the same, right? And then this is the F value that we get, and we would compare it to the F critical, right? That's if we only did that. Now, the beauty of a, hold on, annotate. We also could have just done a one-way analysis of variance that would have looked like this, right? It's only looking at topping. I got to get rid of this. Select, I'm gonna delete this. It could have looked just like this. How come that didn't work? And it just would have had topping with the degrees of freedom at the bottom, and we would have only had that information to look at. But since we're doing it this way, which is a two-way, not only do we get more information, we get to look at both of them, temperature, topping at the same time, in addition to the interaction. And that is a significant bonus. That's a good thing. That interaction, like we said, we saw how it can kind of behave, right? So that's the value of doing a two-way analysis of variance. It's the fact that you get to see all of this, right? Now, got to make sure y'all listening and following me. When we look at the main effect of temperature, right? Was there a significant effect found in temperature? Now we got a couple questions. I need somebody to give me a yes, no. Then I need somebody to tell me how to do it. And then we're going to see another way to do it as well. So do y'all think that temperature was significant or it was not significant? Somebody tell me. You think it was significant?
Yes.
Okay, so we got Jasmine saying yes. Now it's the pressure on somebody else to sit back and say, why? Why do you think it was significant?
The p-value is less than 0.05.
P-value is less than 0.05. See, now I'm saying it the wrong way, trying to be like y'all, right? Now there's another way too. There's another way we could have done this too. There's more than one way to skin a cat. So what else could we have looked at on here to sit back and see that this is a significant impact? Temperature did impact our values. We've been doing this for quite some time. There's always the p-value method, and then we have the critical value method. Uh-oh, somebody talking on the other side of the microphone? I can't hear him. Yes, I gotta help y'all out.
What was the question? I couldn't hear you.
All right. It is, what's the other way that we could tell that temperature had a significant effect? Somebody just stated, I forgot to say quickly, that the p-value is less than 0.05. What's the other way with what's on the screen we could find out that this effect was significant? Okay. The F value is more extreme than F critical. The F critical, we've been doing this all semester. This table is pretty much going into the back of the book for us and saying that for this test, the F critical is 3.875. So we would have went back at 1 degree of freedom and 282 degrees of freedom in the back of that chart, and we would have went and it would have showed us a value of 3.875. Now, when we calculated the F value from this study, we got a value of 4.253. This 4.253 is more extreme than the critical value. So you damn right, we have a significant effect. Both of these things all say the same thing. We went back from Jasmine just being like, yep, I think it is. Maybe that was wisdom, I forget. And then somebody said, oh, look at the p-value. It's right there, Dr. Barnes. 0.04 is surely less than 0.05. I'm right. And another way is to sit back and be like, oh, the F value is more extreme than the F critical. And to show you that, that's got to go back to what we always do with the whole sketch, label, and shade. We'll have a little distribution. Now, if y'all remember before, I kind of mentioned that the distribution for chi is actually a curve. It's not normal, right? But what we do know is that there is a little red area that we'll call the critical region right there. And this 4.253 is beyond where this critical region starts. It starts at 3.875. 3 ways to come to the same conclusion. All right, now let's focus now on the type of toppings, right? Yes.
I have a question.
Mhm.
Is it possible for, all right, so say if the F value and F, like, hold on, get my words together. Is it possible for one of the ways we test to see if a value is significant, is it possible for one of them to be significant and for the other one to not?
You know what? Only when we were talking about confidence intervals before. Remember how, like, and again, I love this because I think it goes to show that there's some of the things that we were reading that it just didn't really sink in, right? but there was always a part of each chapter that was like, we're using the same distribution, right? And since they use the same distribution, they'll always come to the same conclusion, right? That was always referring to this. I just think that this right here is probably the first time I've been able to clearly show you exactly what we're talking about with some real SPSS data. So for this test, absolutely not, right? But there were some chapters previously, and I can't tell you which one they were, but there were some chapters that when you read in there, they'd be like, oh, since the p-value is using this distribution and the critical value is using a different distribution, then it could possibly come to a different conclusion. But that's not the case in this chapter. So your answer that you're asking for today is no. These will always be the same. I 100% promise you. All right. So let's get back to that question I asked though, all right? Right here, when we look at toppings, is toppings significant, yes or no? Don't be scared. I want to get, oh, yes, okay. Yes. All right, now somebody tell me, how do we know that? You can give me one of the, whichever way you like. How do you know?
Because the p-value is less than 0.05.
All right, and what is the p-value?
I don't know how to say that.
Oh yeah, that's right. You know what? The 1.3 e raised to the -29. That's pretty much what it is. 1.3 e raised to the -29. Right? And then what's another way that we could have determined that it's significant?
The F value being more extreme than the F critical.
All right, and what is the value of the F value?
84.985.
All right, and somebody else, what is the F critical that 84.985 had to be more extreme than?
3.028.
Yeah, man, that's hella significant. It's way beyond if we were to sketch, label, and shade. Now, we can do the last thing for we can do the same thing for the interaction. The interaction can be the same way. Now look at the interaction. Is the interaction significant?
No.
Nope. All right. Somebody tell me, why do y'all think the interaction is not significant?
Because the p-value is greater than 0.05.
Okay. And what's that other way that we could sit back and check out as well?
The F value is less than the F critical.
Thank you so much. Y'all got it. Now, when you read the textbook has an approach that tells you about the way to go. I actually went about this the wrong way. We did the interaction last when you really should do the interaction first. And depending on what the result is from the interaction, it determines whether you continue on to read the rest of the table, right? I'm not going to go into that because of time, but when you read, that will be important. And to do the homework and the quizzes and the handouts that you're doing, right? The handout quizzes, that definitely is alluded to all of you. So I apologize for that oversight, and I'm not going to correct it because I don't want to be holding y'all past the end of class on the last day of class. All right, let me see if there's anything else in this PowerPoint that needs to be.
If no one else minds, do you mind explaining that?
Do I mind explaining how to go through the other steps?
Yeah, like if there is, like if you, so like how you look at the interaction value, p-value first, and to determine if you look at everything else. Like if no one else minds, could you go over that?
Yeah, I can do that. All right. So essentially what the step is this. Step number one, I don't have it in here. So like a little visual. So let me sit back and do it. Not stop recording. All right. So step one is you test the interaction effect first. And then what happens is you get kind of an if-then statement from that, right? So if significant, you stop, right? If not significant, proceed to additional factors. Right? So it's kind of an if-then statement. You do the interaction first to see if there's something there. How come this is not working? All right. And depending on how this flow chart works, it tells you what to do next. So if you sit back and you get an interaction effect and you test it and it is, if significant, then you stop right there. And what you're doing is this. Remember how I told you guys that each time you run an analysis, you're running the risk of a type 1 error. Your alpha is at alpha 0.05, right? You want to keep that low. So if you look at the interaction and the interaction is significant, you're going to be like, yo, I'm a chill. I'm not going to waste all my alpha so I can make a mistake. If this interaction is significant, pause. And I'm going to do some other work afterwards to make sure that I don't make an additional mistake, right? But if you do this analysis on the two-way and it's not significant, you still got to find something that works. So then you'd be like, all right, damn, my experiment. Again, these experiments can take a while, right? Even the peanut butter, ketchup, and peanut butter and ketchup thing that we just did right now with their friends, I had canceled class for the whole week. And that's something simple that I did. If you're doing a real psychological research project, you could spend a semester collecting data. You ain't gonna give up because one thing is not significant. So if it's not significant, then you proceed to do the additional factors one by one, which is like the temperature of the bread and then the bread topping. And you're trying to find, and hopefully you will find something, but it's worth taking the risk over here because of all the time essentially that you wasted, right? All the time you wasted, you don't want that to be a waste, right? So you're going to keep looking, right? However, if you find that it works, oh, hell to the no. You want to sit back there and stop, because if you keep on doing a test, you're running the risk of you making a mistake. And you might be in front of a poster, a conference, and somebody being like, Dr. Mays, Lofton, your research is bogus. And they're like, what were you talking about? Yeah, but we've been replicating it for 15 other times, and we haven't had it work the way that you had it work. So that's the reason why, if it is significant, you stop, because the more tests you run, the more chances are that even though you found something good, you can make a mistake. But in the event that it's not significant, you wasted so much damn time, you don't give up that easy. At least I wouldn't tell you to give up that easy. So that's the process right here. I'm just a little makeshift, impromptu, but I think I addressed the question. All right, people, I'm going to stop recording.